Hello friends, today we're going to learn how we can solve the clock angle related problems. So, in this type of aptitude problem, what we get is usually a clock state like current time is 10:25. What is the angle between hour and minute? Or we can also get problem like in the morning 7 o'clock, my clock was very accurate. What, how much degree the hour needle has been moved in afternoon 2 o'clock. So you need to evaluate. Or afternoon 2 o'clock 2:10, like that. So first we're going to evaluate how we can divide per hour, how much hour we get, how much degrees a hand rotate per hour, how much degree a minute needle rotate per minute, and how much hour needle rotate per minute. So we're going to evaluate these because it's going to be very useful. We're also going to generate a generic formula to evaluate the angles. So let's get started. So we already know the angle of the circle is 360 degree. If it is a full circle, it's 360 degree. Now we also know clock has 12 parts because it's divided into 12 hours. So 1 hour is going to take 360 divided by 12, that is 30 degree. So every time our needle move, it creates 30 degree. Now we're going to do something similar for minute also. So we know a minute needle take entire circle in 60 minutes. 60 minutes is entire circle. Entire circle means 360 degree. So 1 minute it will take 360 divided by 60, that is 6 degree. So every minute tick, one tick, and it's 6 degree. Okay. Now we also want to know how much a clock takes when a minute needle move one tick. How much does our needle move? Okay. So an hour is 30 degree. An hour has 60 minutes in it, 30 degree. So 1 minute, our needle will move 30 divided by 60, that is 1 by 2 degree. So you can also evaluate that, because in 60 minutes the hour will move 60 into 1 by 2, that is 30 degree. That is what we already proven. So now we have these three observations. With these three observations, we're going to generate a formula as well. Okay, so now we're going to create the generic formula. So let's say what we know is there is a condition like what is the angle between hour and minute at x time, h hour and m minute. To evaluate that formula, we're simply going to do a simple logic. Let's say our clock is at 3, 4, 5, 6, 4:30. So our hour will be somewhere north of 4, somewhere between 4 and 5, and minute will be somewhere in 6. So what we're going to do, we're going to calculate the angle of hour A, how much hour is moved. Then we're going to calculate the B, how much minute has moved, hour move, minute move, and then we're going to reduce minute to hour. It can also possible that a minute needle is forward and hour needle is backward. In that case, this answer will be negative, and you can just ignore the negative sign. It's like minute needle, hour needle is somewhere here, a minute needle is somewhere here, so the A will be bigger than B. So what we learned if we calculate from 12 a minute angle, calculate from 12 hour angle and reduce them, we get the angle in between. So now we need to create a generic formula how we calculate. So the how much our needle has moved. First thing, for h hour, it moved h into 30 degree plus for every minute it moved half second into, so if from 12 the minute needle already moved till 30, so it has already moved 15 degrees, so into 30. So because we want to create a generic formula for m minute is simply m and minus how much minute have moved. 6 degree per minute needle moves into m. And if we simplify this, this is 30h minus 11 by 2m. So this is the simple formula to calculate the angle at any given time. So we're going to use that also. Now let's go into first problem. So our problem is the accurate clock shows 8 o'clock in the morning. So we create a clock. This is 9, this is 8, this is 7, this is 6, this is 12, this is 1, this is 2, this is 3. In the morning, so our clock is here. So how many degree hour will rotate at 2 at afternoon? 2 at afternoon here. So this is what we need to calculate. So this is very simple task. We can calculate how much it moves. So first we will calculate how much it moves 8 to 12. That is 12 minus 8. That is 4. Then how much it moves from 12 to 2? 12 to 1, 1 to 2, that is 2. So total degrees is 6. And I know for every hour our angle is 30 degree. So 6 into 30 will be our answer. That is 180 degree. And we got the answer. Now we move on to next problem. So what this problem says, a clock is started at noon. That means the clock started right at 12. That is the noon time. By 10 minutes past 5, this is our 6, this is 5, this is 4, this is 3. And our clock is somewhere 5, not the 5 because it's already 10 minutes and this is, let's say 2, this is 1. So our minute angle is here. So what is asking this angle? The question is this angle. So we already calculated the formula for hour. So total hour into 30 plus half of the total minute. So we're going to put that in 5 hour into 30 plus half of the 10 minutes past 5 into 10. So is 150 plus 5, that is 155, and that is our answer. Now we're going to solve another problem for which we actually generated a good formula. The reflex angle between hand of a clock at 10:25. So that means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, like that. So the reflex angle you want to know at 10 and 25. So we just remove this. Hour needle is here and minute needle is here. This is hour, this is minute. And wants to calculate the reflex, this angle. So the formula we created, hour into 30 minus 11 by 2 and minute. We're going to substitute. Hour is 10, from 12 to 10 is 10 times. 10 into 30 minus 11 by 2 into 25. Into 25. That gives us 300 minus 25 1 25 one time and 25 1 time 25 plus 2, 27 divided by 2. That is 600 minus 275 divided by 2. That gives us about 325. 325 divided by 2 degrees, and that is our answer. Simple as that. Always remember the formula and do it in a minute.